In order to improve performance, reliability, and support large disk volumes, Microsoft developed NTFS file system for Windows NT in early 90s. NTFS is still widely used today. NTFS is a robust journaling file system. Changes in the file system are first recorded to a log file, then written to the disk. It enhances security by storing permissions for each file and directory. The size of a cluster in the NTFS file system ranges from 512 bytes up to 64 kilobytes. To support a smaller disk volume with mostly small files, you can create smaller clusters to reduce wasted disk space. If you use a large disk, you may create bigger clusters to save read-write performance and reduce file fragmentation. NTFS uses 64 bits for each cluster's address. Therefore, NTFS can support up to 2 to the 64 powers number of clusters. The key component of NTFS is master file table, or MFT. Like the boot record from a FAT file system, an NTFS volume boot sector begins in the first sector of the partition, can use up to 16 sectors. It contains the cluster size, the address of MFT in logical sector numbers, the address for the MFT mirror, which contains the copies of the first 4 entries from the MFT as a backup. If the partition is bootable, the boot sector also contains the program code to load the NT loader. Master file table is a system file, and its file name starts with a $. The master file table is created when the NTFS volume was formatted. The MFT records each file and a directory on the volume, including an entry for itself. Each file uses one or more MFT records to store metadata information in attributes $file record head, $stand information, $file name, and data. $file record header includes MFT number, link count, file type, file size, etc. for this file. Standard information contains the file's MAC times and the characteristics telling whether the file is a hidden file or a system file. $file name contains the file name that can be up to 255 characters. The data attribute normally lists all the cluster addresses allocated to the file. The file content will be stored outside of the MFT record in clusters. However, a small file may have its content held entirely in the $data attribute inside its MFT record. What do I mean by a small file here? If an MFT record is 1024 bytes in size, files that are less than 740 bytes are considered as small files. I will demonstrate this scenario later. If a file's metadata information is larger than 1 MFT record, NTFS uses 2 or more MFT records to contain the file's attributes. It uses the attribute $attribute list to point to all of the other records in the MFT. There is a flag in each record to indicate the MFT record's allocation status. This flag is set to 0 when the record is marked for deletion, also known as unallocated. Each directory record uses attribute $index root to list all its children. More specifically, each child residing in this directory is represented by an index entry holding the information of its file name and its standard information. $index root contains a list of its children's index entries. $root is sorted based on file names in either ascending name order or in a B tree structure. When a folder contains index entries that cannot fit in one MFT record, the additional index entries are stored in index buffers. The $index allocation attribute stores the locations information of these index buffers. The first 16 files in MFT are the system files. The first file is $MFT itself. The $bitmap file keeps track of clusters usage. It uses 1 bit to record the status of each cluster on the volume. If a cluster is in use, the corresponding bit is 1, otherwise the bit is 0. When you create a file on an NTFS volume, one or more free clusters are chosen from the bitmap file. An MFT record will be created to store the file's file name, standard information, and its cluster's addresses. Its index entry is inserted in the correct sequence in its parent's $index root attribute. When you delete a file on an NTFS volume, its cluster references in the bitmap file are changed to 0. The MFT record for that file is marked for deletion, that is, the flag for allocation status is set to 0. The index entry for the file is removed from its parent's MFT record. Consequently, in $root, the index entries below it will be moved up, overriding the deleted entry. Therefore, in NTFS, it is common for a deleted file to lose its parent folder's information. As long as the clusters holding the file data have not been reallocated to other file, a segment of the file is still recoverable. If the MFT record is still available, we can possibly get all the clusters' locations to recover a file with its file name. Since we lived in the age of information, there is a demand for a file system that can support large storage, such as multi-terabytes drives, and also provide continual reliability. Windows introduced a new file system called Resilient File System, REFS, first used in Windows Server 2012 and Windows 8. As of now, the Resilient File System is still not ready to completely take over as the default file system, and a forensic investigation procedures for Resilient File System are still being developed.